A starship on the moon is not the whole story. A starship sits on grey lunar dust beside robot builders and a strip of factory lights. If you watch only for a moon city, you miss the machinery that could matter most. The costly mistake is calling this a moon city, then looking only for homes, roads, and domes. The reversal is that the first lunar city may not begin with houses, it may begin with a supply chain. That is the sharper, unanswered question behind the fascination with SpaceX factories and lunar cities. A factory tour shows how SpaceX tries to build rockets on Earth at industrial speed. A moon city video shows the dream those rockets might serve. But between those two images sits the missing system: how cargo becomes equipment, how equipment prepares the ground, how the ground supports more landings, and how each mission leaves behind something that makes the next one easier. To be clear, this is not a claim that SpaceX has announced a complete lunar factory plan. It is not a leaked timeline. It is not a promise that glowing work sites will appear on the moon soon. This is an exploration of a possible pathway. If Starship-scale transport, automated construction, lunar materials, power, storage, and repair ever connect, the moon stops being only a destination. It starts behaving like a machine that can help build itself. So if the city is not the first target, what is the first piece of lunar infrastructure that makes everything else possible? The question is rising now because two different obsessions have started to collide. On one side, viewers are watching SpaceX factories on Earth with unusual intensity. They want to see how rockets stop looking like rare national monuments and start looking like products moving through an industrial line. Starfactory, as an idea and as a public image, is interesting not only because it shows machines, workers, steel, and speed. It is interesting because it suggests a method: simplify the vehicle, repeat the process, learn from failures, and build again. On the other side, Moon City concepts keep pulling audiences toward a future that feels almost cinematic: domes on the horizon, roads across dust, starships standing upright beside habitats, lights under a black sky. It is easy to understand why that image works. It gives the moon a skyline. It turns a hostile landscape into somewhere people can imagine living. But this story is asking a narrower and stranger question: not what is inside Starfactory, not whether SpaceX has secretly scheduled a city on the moon, and not whether a Mars survival plan can simply be copied onto the lunar surface. The question is whether the logic of a factory can migrate off Earth before the city ever arrives. That distinction matters. A city is a human story. A factory system is an operational story. It asks what has to happen every time cargo lands, how the surface is prepared, how machines are powered, how dust is controlled, how broken equipment is repaired, how each delivery leaves the next crew or the next robot with a slightly easier job. The evidence has to be handled carefully. Public interest in SpaceX factories, Star Factory style manufacturing, lunar cities, and survival plans for Mars is real enough to notice. But audience demand is not the same thing as an official plan. Thin keyword signals and popular videos can show curiosity. They do not prove a timeline, a budget, a construction sequence, or a completed lunar factory blueprint. So the safest way to watch this story is as an industrial possibility, not a prediction. The known facts are simple. SpaceX is developing large, reusable spacecraft. The moon has local material in the form of regolith. Any serious lunar operation would face severe limits on what can be shipped from Earth. The theory is that heavy transport, automation, power systems, surface construction, and local materials could eventually connect into something repeatable. The speculation is how far SpaceX or anyone else could push that loop and when. The surprising part is that this makes the moon less like a destination and more like a test of manufacturing itself. On Earth, a factory is where products come from. On the moon, the first product of a factory might be the ability to keep building. Before there is a city, there has to be a work site. And before that work site can grow, it has to solve problems that look almost too ordinary for a moon documentary. where to land, how to unload, where to plug in power, where to park machines, how to keep dust away from delicate hardware. What happens when something breaks? That is the reversal at the center of this story. A lunar city is the image people remember. It gives the imagination something to hold on to. Pressurized tunnels, vehicles moving between habitats, people looking back at Earth from a place once seemed unreachable. But a city is not the first machine. A construction system is. And if SpaceX ever plays a major role in building on the moon, the most important early question may not be how many people live there. It may be how many repeatable operations can happen without turning every mission into a one-time stunt. A one-off mission can be heroic. It can survive on careful preparation, huge support from Earth, and a narrow set of objectives. A factory system is different. It has to repeat. It has to land cargo without destroying the next landing zone. It has to unload equipment in low gravity, abrasive dust, vacuum, and extreme temperatures. It has to prepare the surface, distribute power, shield vulnerable parts, store supplies, move materials, and recover from failure. In other words, it has to behave less like an expedition and more like a production line. This is where Starship changes the imagination, but only cautiously. SpaceX is developing Starship around the idea of large-scale reusable transport. If that approach works as intended for lunar cargo, and if the needed mission architecture can support it, then the menu of possible moon equipment changes. Instead of thinking only about small scientific instruments or single-purpose landers, planners could begin to consider heavier construction machines, larger power systems, modular shelters, storage tanks, robotic handlers, spare parts, and tools designed to stay. The word "if" matters. This is not a claim that SpaceX has a public, finished blueprint for a lunar factory. It is an industrial logic exercise. If transport becomes more capable, the next bottleneck becomes surface operations. If surface operations become repeatable, the moon stops being only a destination and starts becoming a place where infrastructure can accumulate. And that first infrastructure may be deeply unglamorous, not a shining city, not a glass habitat, not a rocket assembly line under lunar floodlights. The first useful products of a moon factory might be landing pads that reduce dust and debris, berms that protect equipment, graded routes between work zones, simple shelters for machines, tanks for storing consumables, power distribution, and standardized parts that make repairs less dependent on Earth. The real milestone would not be the first dramatic arrival. It would be the moment each arrival leaves behind something that makes the next arrival easier. And that leads to a stranger possibility. The first factory product may not be a rocket part or a habitat. It may be the ground itself. The moon is covered in regolith, a layer of broken rock, powder, glassy fragments, and dust shaped by impacts. Harsh exposure over enormous stretches of time. To the eye, it looks like grey emptiness. To an engineer, it is a problem. It can cling to machines, grind into joints, block seals, and make every moving part more vulnerable. But to a future builder, it is also the one material that is already there. This is the uncomfortable reversal at the center of lunar construction. The same dirt that threatens the machines may also be the raw material that saves them. On Earth, construction begins with supply chains so familiar that they almost disappear. Cement comes from one place, steel from another. Glass, wire, machines, fuel, spare parts, tools, and workers move through ports, highways, rail lines, and warehouses before a building ever rises. On the moon, none of that exists at the beginning. Every imported object has to be launched from Earth, moved through space, landed safely, and then used in an environment. Does not forgive simple mistakes. So the obvious question becomes, what can be stopped from leaving Earth in the first place? That question is the simple logic behind in situ resource utilization. The phrase sounds technical, but the idea is plain. Instead of carrying every wall, pad, shield, and spare construction material from Earth, a future lunar work site would try to use local material. Not because lunar dirt is convenient in the normal sense, it is not, but because local material does not need a rocket ticket. Here, the line between fact and speculation matters. It is factual that the moon has regolith. It is factual that the lunar surface is extreme, with vacuum, radiation exposure, abrasive dust, and severe temperature conditions. It is also factual that researchers have studied ways to turn lunar soil-like materials into useful construction elements, but it is still speculative how efficiently any future system could process real lunar regolith at industrial scale, continuously, safely, and cheaply enough to matter. Some researchers suggest that concentrated heat or microwaves could sinter regolith, fusing loose grains into harder surfaces. In theory, that could help create landing pads, roads, or work zones that reduce dust kicked up by engines and wheels. Others explore blocks, bricks, berms, or shielding made from local material. A berm does not sound futuristic, but on the moon, a pile of processed or placed regolith could become protection, structure, or traffic control. It could shield equipment, it could shape a landing area, it could separate dangerous zones from delicate ones. More advanced ideas go further, into extracting oxygen from minerals, processing metals, or using regolith as feedstock for manufacturing. Those ideas are not the same as near-term SpaceX operations. They belong in the category of research directions and future possibilities, not guaranteed milestones. The difference is crucial. A documentary can follow the industrial logic without pretending the factory already exists. For SpaceX or any organization trying to build beyond Earth, the strategic prize would not be a single brick. It would be a repeatable process. Land equipment, prepare surface, use local material, make the next landing safer, protect the next machine better, reduce the next shipment from Earth, then repeat. That is how dirt becomes inventory. On the moon, dirt is not scenery, it is the first inventory. And if lunar dirt can become infrastructure, then the next bottleneck is not imagination, it is energy. A factory on Earth hides this problem behind walls, plugs, cooling systems, warehouses, roads, shifts, maintenance crews, and delivery trucks. The lights turn on, machines warm up, replacement parts arrive. A broken tool can be pulled from the line, repaired, and replaced before the entire operation collapses. On the moon, none of that background support exists by default. This is the reversal at the center of the power problem. The hard part may not be landing a machine on the surface. The hard part may be keeping that machine useful after the first demonstration is over. Factually, the moon is an extreme place for hardware. It has vacuum, it has abrasive dust, it has radiation exposure, it has harsh temperature swings between sunlight and shadow. In some locations, shadows can be long and operationally difficult. Communications with Earth are not instant in the ordinary Earth worksite sense, and some areas require relay systems or careful planning. None of those conditions makes construction impossible, but all of them punish fragile assumptions. A lunar factory system would need steady power, but also storage for when power is interrupted. It would need thermal control, because machines that overheat or freeze are not productive machines. It would need scheduling, because digging, sintering, hauling, charging, cooling, inspecting, and repairing cannot all happen at random. It would need diagnostics so operators know what is failing before it becomes mission-ending. And it would need some mix of autonomy, remote control, spare parts, and human or robotic intervention. That is why the phrase off-world factory can be misleading if it only makes us picture machines lined up on grey dust. A real factory is not a collection of equipment. It is a system of dependencies that keeps equipment alive. This is where SpaceX becomes relevant, but only cautiously. SpaceX is publicly known for pushing high-rate production and launch operations on Earth. Its factory culture is part of why so many viewers are fascinated by Starfactory and the company's manufacturing process. But translating that logic to the moon is not a proven extension. Earth gives factories air, gravity, weather protection, workers, suppliers, roads, cranes, and emergency response. The moon gives none of those things for free. So the mystery is not simply whether SpaceX could deliver construction equipment, it is whether a future lunar architecture, SpaceX led or involving many partners, could create an operating rhythm. Charge the machines, move the material, protect the joints from dust, keep electronics within limits, swap worn parts, diagnose faults, patch software, store power, repeat the process until the worksite improves instead of decays. Some researchers suggest that early lunar construction may depend less on dramatic breakthroughs and more on disciplined operations, simple machines that do narrow jobs, redundant systems, and infrastructure that grows in small, practical steps. One theory is that the first real proof of a lunar factory will not be a glowing habitat or a beautiful dome. It will be a repair that happens without waiting for Earth to rescue every failure. That is the concrete takeaway. The first machine landing is a milestone. The first broken machine returning to service may be the beginning of industry. The Moon Factory race, if it emerges at all, may be decided by the least cinematic question: can keep the machines alive after the cameras leave. If every landing makes the next landing safer, the Moon stops being only a destination and starts behaving like infrastructure. That is the quiet shift at the center of the whole idea. Not a finished city, not a glowing dome on the horizon, a sequence, a work site that remembers what happened before and uses every mission to make the next one less fragile. In a cautious SpaceX lunar scenario, the first step would not be dramatic. Cargo arrives, machines unload, the surface is inspected, leveled, compacted, or protected. Power units are deployed, connections link equipment, storage areas are marked. Regolith is moved away from sensitive hardware or toward places where it can become useful. Then the first construction systems begin turning loose material into something more permanent. Pads, berms, shelters, roads, equipment stands, thermal covers, or protective walls. None of that requires imagining a full lunar city on day one. It requires something more basic and maybe more powerful: repetition. The second mission lands on a site that is slightly better than the first. The third mission uses tools that were left behind. The fourth brings replacement parts instead of rebuilding the entire worksite from scratch. The fifth expands the power system. The next one adds more storage, more shielding, more machines, and more ways to recover from failure. This is where a base becomes something else. A base is a place. A factory system is a habit. That habit is what makes the Moon interesting as a testbed for deeper space. Mars survival plans often capture the imagination because Mars feels like the final exam: distant, dangerous, and emotionally enormous. But the Moon may be the harsher classroom that is close enough to correct mistakes. It is still hostile. It still has dust, vacuum, radiation, thermal extremes, and limited rescue options. But compared with Mars, it is nearby enough that early industrial lessons could be tested, revised, tested again without pretending Earth has disappeared from the equation. This does not mean SpaceX has publicly committed to this exact sequence. It does not mean a nation, company, or agency has already won some lunar factory race. That language is useful only as an analytical frame. The real question is simpler and more unsettling. Who can learn to make infrastructure off-world in a repeatable way? Because once construction becomes repeatable, every other ambition changes shape. Science missions could get safer landing zones and better equipment shelters. Commercial operators could imagine shared power, storage, maintenance, and communications. Exploration teams could arrive at places that already have prepared ground instead of untouched dust. And if SpaceX-style manufacturing logic ever migrated from Earth factories to lunar operations, the advantage would not only be rockets, it would be the ability to leave behind a little more capability every time. That is the strange possibility behind the factory lights on the Moon. The story may not begin with a skyline. It may not begin with a dome. It may not even begin with people. It may begin with a landing pad that makes the next landing safer, a power unit that keeps the next machine alive, a repaired robot that proves the worksite can recover, and a patch of lunar dirt turned from danger into inventory. The first lunar city may not begin with houses, it may begin with a supply chain. And if you want to follow the next pattern in how rockets, factories, and off world construction start to connect, subscribe for the next episode. Because the real moon story may not be who gets there first, it may be who learns how to keep building after arrival.